Hi and welcome to Down the Shed. So experiment 13, the electronic switch. So we'll connect the wires according to the wiring checklist. Although there is a closed circuit with the battery, 1k ohm LED and transistor, no current will flow since the transistor is acting like an open circuit with no base current. The lever arm remains shut. Press the switch. A base current now flows and opens the lever arm, resulting in a large collector current which lights the LED. The transistor is being used as an electronic switch. Although there is still a normal switch in this circuit, there could be many electronic switches controlled by one normal switch. So basically, as we discussed when we read up on the transistors, this is basically an electronic switch, and even though we've got circuit going through the entire circuit, until we press the switch it won't put any current through the base. So in transistors, the emitter, base and collector are different regions of permanent electrical charge, producing the effects described for the lever pivot. The properties and uses of transistors may seem confusing at first, but will become clear as you proceed through the experiments. All but one of the remaining experiments shall use the transistor, so its importance for electronics should be apparent. So basically, in the water pipe analogy, the bipolar junction transistor may be thought of as a lever pivot. Include a check valve that is connected to a lever arm. A small amount of base current pushes on the check valve, which turns and opens the lever arm. But before this base current can start to flow through it, must have enough water pressure to overcome the spring in the check valve, usually 0.7 volts. If the base pipe is much smaller than the collector and emitter pipes, then a small base current flowing in will cause a large collector current to flow in. These will combine and exit the device as emitter current. Right, so I'll just take the diagrams up to the camera so you can see them. I'll do it on the 1080p and I'll show you the symbol for an NPN transistor. This only contains NPNs, not PNPs. Again, I'd have to research the difference between the two. And then we'll have a quick look at the schematic and the wiring diagram. There's the water analogy and the diagram for a transistor, and we've got the schematic and the wiring checklist with wiring diagram. So let's wire this puppy up. So 41 1k resistor to 27 positive of the battery, 27 to 56, that could be a small one, that'll be the switch. So positive to switch. The switch basically like this, you can get them either way around, it will make absolutely no difference to the circuit. We'll check that in a while. 55 to 45, so switch to 10k, (44 to 15), 10k to where's 50? There it is. So that'll be the 10k to the NPN transistor. So I think they're all semiconductor, transistor, which are, this is called it semiconductors. I think all three are exactly the same. So basically we just got three transistors or semiconductors on there. 17 to 26. So transistor to battery negative. Just about to stretch that one over. Ooh. Can we? Yes, we can. 17 to 26, 40 to 1. Now we'll do a long one for that. Where's 40? 40. So that'll be the 1k to the positive of the LED, or the anode, and 2 to 16. So the cathode back to the transistor, or negative. So the battery's connected, the circuit's in place. Let's turn the big light off and turn this one on to low beam. why I like the safety circuits for night time. I sometimes practice them in the day, and then I might even kill that one totally in a minute. Let's see how it lights up on here. So we'll press the switch and the LED lights up. So we'll kill this one quickly. There we go, nice bright LED. So as I was saying, you can basically reverse the switch as it's simple open or shut. It really makes no odds. And as you can see, the LED still functions. So that is basically the transistor circuit. Once we put the power through the base, it opens up the current between these ones. As you can see, the negative goes to the transistor goes to the negative of the LED. We've got the positive coming from the battery itself. So the battery positive goes to the switch goes to this resistor then goes to the base of the transistor. Let's put some light back on. So I'll just show that again. Battery positive to switch to resistor to the base of the transistor. So when we put the power through the battery, it allows the transistor to open up and send the power back to here. So that is a basic transistor circuit. Let's see if we get some more light on me. That's a basic transistor circuit, number 13. Like the video, subscribe to the channel, and in the next exciting, oh, we do have another water analogy. In the next exciting project, I say exciting loosely, I do really need to get hold of the old Tandy or Realistic 150 and 201 kits. I used to love those as a child. This is basically the modern version of things I had when I was a kid. So yeah, experiment 14, the current amplifier. So that'll be our next issue. Thanks for watching, and I'll see you in the next one.